Assalamu alaikum, dear students. This is the continuation of A2, chapter 12. And of course, you know that we are talking about the 9702 syllabus of physics. And here we have the new topic, the angular velocity. Again, the same thing. This is a continuation of the previous discussion, where we have discussed angular displacement. So, what was the angular displacement? The angle subtended by a body moving in a circle at the center of the circle, and how we were representing that by using theta. Very simply, here we can say that what is angular velocity? So, rate of change of angular displacement. Rate of change of angular displacement is your angular velocity, and we will represent this by omega. तो ये जहन में रखिए कि ये हमारे पास जो है वो सिंबल है ओमेगा, जिससे हम इसको रिप्रेजेंट कर रहे हैं, इस चीज़ को, एंगुलर वेलोसिटी को. तो दिस इज़ इम्पोर्टेंट और बहुत ही आसान डेफिनेशन. द रेट ऑफ चेंज ऑफ एंगुलर डिस्प्लेसमेंट, as we have already discussed in your linear displacement or linear discussion, that the simply if you will go from displacement to velocity, the rate of change of velocity, and here we have rate of change of angular velocity. So only the difference of this word angular. And why? Because we are now dealing with the angular motion or circular motion. How you can write this equation? Rate of change of angular displacement. So simply omega is the representation, and you know that change of angular displacement is delta theta, and change of time is delta t. So this is simply very simple equation, you can say, and here we can write it as omega is equal to delta theta over delta t. So the rate of change of your angular displacement is simply giving you angular velocity. And as you know that the angular displacement we can measure in degrees, revolution, radian, rotation. So simply if you will use these units for angular displacement, of course you know that the unit of time is second. So degree per second, revolution per second, radian per second, and your rotation per second, all these are possible units of your angular velocity. But in most of the cases you will see that either we are talking in terms of the degree per second or radian per second, but sometimes you will see that you are using the rotation per second or revolution per second as the unit of your angular velocity. Of course, you know that angular velocity, as you know that velocity is a vector quantity, so angular velocity is also a vector quantity. Here it's not very, you can say, it's important but not necessary to remember, but I think if you will remember, it will be a good thing, that you should know that how you will find the direction of the angular velocity omega. So here we have a simple right hand rule, you can say, when curling of fingers of right hand shows the direction of rotation or revolution, then the thumb of the right hand indicates the direction of the angular velocity. So you will use your right hand, keep your right hand up and rotate the fingers of, or curl your fingers of right hand in a direction, and you will see that the thumb is indicating the direction of the angular velocity. So if you will rotate your fingers anti-clockwise, like here we have the situation, when you will rotate your fingers or when you will curl your fingers anti-clockwise, you will see that your thumb is indicating the upward or out of paper direction. So direction of the omega or direction of the angular velocity will be out of the page or out of the paper when your right hand fingers will move in or will curve in the anti-clockwise direction. Similarly, over here, if you will use your fingers clockwise, then you will see that your thumb is indicating downward, or simply you can say that into the paper is the direction of the angular velocity. So into the paper or downwards, here you can write downwards as well. So the downward direction, and here we have upward direction for the angular velocity. So this is something which is very important. So remember this thing, that the direction of the angular velocity is upward or downward according to the curling of your fingers of right hand. Then we have the relation between linear and angular velocities. As in the last discussion, we had discussed this S is equal to R theta. So by taking help from this concept, that the rate of change, if you want to find out, that you have to divide both sides of the equation by delta t. So when you will divide both sides of equation by delta t, you will find that here you have the situation of the rate of change of linear displacement. Here you have the rate of change of angular displacement or distance. So you better write displacement, angular displacement, rate of change of angular, rate of change of angular displacement. So the thing is that radius is a constant factor. So you can say that radius is a constant when we are talking about a body which is moving in a circle of radius r. So this is what we have. This is the center of the circle O. This is your point which is rotating in the circle, and the initial position is say P. After some time it will be somewhere here. The new position delta is your P dash. So delta T is the time interval and arc is a delta S. So from P to P dash or P to P dash, like this, you will have a distance, and of course the rate of change of angular displacement is giving you the linear velocity and angular velocity relation. So V is equal to R omega. This is your equation which is giving you the relation between the angular and linear velocities. So this is important to remember. Then here we have the continuation of the discussion, and you know that we can develop a relation between angular velocity and time period. So you know that if you want to define time period, the time to complete one revolution or rotation by a body in a circular motion. So this is the definition of your time period. And you know that if the body is moving from the, suppose here we have the point P, and the body is completing the rotation. So what will be the situation? So you said that the body will complete a rotation and the time period will be capital T. Now the thing is that when you will cover this distance in a complete arc, so you know that this is nothing but 2 pi r. So this is something very important. As far as the angular displacement is concerned, you know that it is 2 pi radian or 360 degree. So if you will use your equation for the angular velocity, so which is your equation delta omega is equal to delta theta over delta t. So you can very easily relate omega and the other factor or other quantity which is t. So 2 pi radian is the complete angular displacement or 360 degree you can write even, and delta t is the time, and over here the t is basically the time period. So simply you can write that omega is equal to 2 pi over t. Yani what you did here, you have used 2 pi radian for delta theta because this is the complete angular displacement here, and of course the time for this rotation will be time period, so you have used your t. So omega is equal to 2 pi t will be the new equation. So this is something which is important to remember. Then again a very simple continuation, you can say that after time period we have another quantity which is frequency, and the number of rotation or revolution per minute or per second, any unit per unit time, will give you the frequency. The number of rotation per unit time or number of revolution even you can write. So number of rotation or number of revolutions per unit time will be the frequency. So you know that it is represented by small f. You also have studied this in your IGCSE or O level, that what is the relation between time period and frequency, and you know that they are reciprocal to each other. So simply you have been writing t is equal to 1 over f or f is equal to 1 over t. So in the previous discussion, or in the equation omega is equal to 2 pi over t, you can very simply say that if we can have 2 pi over t in this form, so even we can write the equation in this form, which is 2 pi into 1 over t. So as we just discussed that 1 over t is nothing but f. So omega is equal to 2 pi f. So this is something, and that's why we use the term angular frequency. And here we have the linear frequency. So omega is also termed as the angular frequency. This is also the term we can use for angular velocity, and particularly when we are relating the angular frequency and the linear frequency, then this will be a better, you can say, a relation, or simply we have been using the term f and omega. So how we can use this? Omega is equal to 2 pi f. Here you have the you can say summary of the equations. That equations here we have used in this discussion and the previous one. First equation is S is equal to r theta, which is giving us the relation between linear and angular displacements. Then we have the second equation, where we had discussed your linear velocity and your angular velocity, and the relation between these two is equal to v is equal to r omega. Then we discuss the third equation, which is for your angular velocity, and this angular velocity is basically giving you delta theta over delta t. So this is something, and a little, you can say, modification for this equation is giving us 2 pi over t and 2 pi f. So all these three equations are basically same equations, you can say, and we have just changed the quantities from delta t to capital T and from capital T to f. So this is something which is very simply you can understand, and these equations are not very difficult. But as I said in the previous discussion as well, that all these equations are very important when you will discuss the other you can say topics of this chapter, and not only of this chapter but coming two chapters of you can say mechanics, which are you can say oscillations and gravitational fields. So these two chapters will also use these equations. So remember this thing, that this is very important set of equations, and you have to remember these things. So I hope that you have understood this, and share and subscribe this channel if you have not subscribed as well as yet. And I think if you will follow these topics and the lectures, then inshallah you need not to go to anywhere else, and very simply you can understand these chapters. Inshallah we will continue this in this chapter, and then you can say in the next chapter, in the next lecture, we will discuss new topics of this chapter. Till then, Allah Hafiz, take care.